Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be learning about interprocess communication, which comes under first unit. And before we get started, if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. And we are now available in our socials. Instagram and Facebook have mentioned the IDs in the description. Please do follow us in our socials. Now let's get started. So now we are in interprocess communication, and so far we have completed these many topics, and now we are in interprocess communication. And interprocess communication. So what is interprocess communication? It means the way in which processes communicate with each other. So there are several processes running in our system, and these processes need to communicate with one another, and the way these processes communicate with one another is known as interprocess communication. That is, there will be many processes running in the operating system, and each process need to communicate with one another. And how these processes are going to communicate is what we call it as interprocess communication. Okay, there are processes executing concurrently in the operating system, and they may be of either independent process or cooperating processes. So that is what is given here. Process executing concurrently in the operating system may be either independent processes or cooperating process. Concurrently means these processes will be running at the same time. That is what they say. These processes can be of two types, either independent processes or cooperating processes. So process can be divided into two types, independent process or cooperating process. Now let's see about what is independent process and what is cooperating process. So independent process, a process is independent if it cannot affect or be affected by other processes executing in the system. Any process that is not going to affect other process, or it itself is not going to be affected by any other process, is called as independent process. Any process that does not share data with other process is independent. So when we say a process is independent, it is not going to communicate with other process. Communicate in the sense, it is not going to share data with other process, and it is not going to make use of the data from other process. So it is extremely independent. So it's not going to communicate with other process. Such process we call it as independent process. So what is a cooperating process? A process is called as a cooperating process if it can be affected or which it can affect or can be affected by other process executing in the system. We call that process cooperating process. That is, any process that share data with other process is a cooperating process. So it will be requiring data from the other process, and it has to share the data with other process. So such process we call it as cooperating processes. All right. So if one process is sharing data with the other process, it means that the process can be affected by the process with which it is sharing its data. And same way, if two processes are sharing data, it means that those two processes can be affecting each other. So when we see this, this interprocess communication will be required in cooperating process, where the processes are communicating or sharing data between each other. So there are several reasons why we go for cooperating process, and we will be seeing the reasons one by one in the next slide. All right. Reasons for process cooperation. There are several reasons, and the first main reason is information sharing. There are several users who are trying to access the same piece of information, say for example a shared file, at the same time, which means when several users are interested in accessing the same information, we must make sure that the information is accessed by all the users concurrently, which means all the users are when they try to access the same piece of information, it it should be available for all of them at the same time. And information sharing is one main reason why we go for process cooperation, as different users are able to access the same information with different processes. All right. So next reason for process cooperation is computation speed. In order to increase the computation speed, what we have to do is we have to divide the main task into several subtasks, and all the subtasks has to run concurrently. That is, all the subtasks should be performed at the same time, so that when once all the subtasks is completed, they can be combined or they have to communicate with each other in order to complete the main task. So by doing this, we can increase the computation speed. So what happens is that we need not wait for one entire task to complete from the starting till the end in order to start the next task. It is like we are dividing the main task into several subtasks, and once all the subtasks is completed, they are combined to complete the main task. This will invariably increase the speed of the computation. So this is one of the reason why we need to have a process cooperation, because all the subtasks need to communicate with each other. Subtask will be having invariably having different processes, right? So all the processes of all the subtasks need to communicate with each other in order to complete the main task. That is one of the reason why we go for process cooperation, in order to increase the computation speed. All right. The next reason is modularity. That is, modularity means we want to design the system by dividing the system into separate modules. So there won't be one person designing the entire system. Each module will be designed by separate people, and these modules need to communicate. That is, they have to cooperate with each other in order to complete the entire system. For this purpose of achieving modularity, we need process cooperation. This is one more reason. Okay. The next reason is convenience. When we allow processes to cooperate with each other, or when we provide an environment where processes can cooperate with each other, it becomes more convenient for the user. That is, for example, a user might be listening to music, printing a document, and typing some information at the same time, and all these processes are running concurrently, and they have to run smoothly in order to avoid system clashing. So for this purpose, we need process cooperation, as all the processes should run smoothly, and it becomes more convenient for the user when he does all the work simultaneously. All right. So convenience is one main reason why we go for process cooperation. So far these are the main reasons why we go for process cooperation, and now let us see about how process cooperation is achieved. That is, cooperating processes require an interprocess communication mechanism that will allow them to exchange data and information. So now let us see how this interprocess communication mechanism is actually implemented. All right. So when processes need to cooperate with each other, they have to communicate with each other. So in order to achieve that, we have to implement interprocess communication, so that processes can exchange data and information between them. So for achieving this interprocess communication, we have two fundamental models. One is the shared memory, and the other one is the message passing model. Okay, now let us see about these models in detail. Okay. First one is shared memory model. What they have given is a region of memory that is shared by cooperating processes is established. So when process P1 wants to share information to process P2, it will establish a shared memory region of its own memory region, and it will write information on the shared memory region, so that process P2 can read from the shared memory region. Okay, and processes then can then exchange information by reading and writing data to the shared region. So this is what I said. Well, process P1 declares the shared memory region and it will be able to write into the shared memory region, and from which the process P2 can read the information written by process P1. Okay. The next is that message passing model. Actually, what happens is that communication takes place in this message passing model by means of messages exchanged between the cooperating processes. Now, let me explain the shared memory model and message passing model with the help of a diagram so that you can visualize actually what happens. All right. So this is the diagram which I was talking about. The first one is the shared memory system. The second one is the message passing system. In shared memory system, process P1 is establishing a shared region of P1. So this is the shared memory region. So wherein the process P1 will be writing data and information which it has to or which it wants to share with process P2, and process P2 will be able to read the data written by process P1 from the shared region of memory. And there is a kernel, and there can be n number of processes in between. After P1 there is a P2, and after P2 there can be P3, and it can be many processes which is sharing the shared region. Okay, this is shared memory model. Whereas the second picture is that message passing model. This M represent the message that is getting exchanged between the processes. Here what happens is that this message process P1 will write this message to the kernel, and from the kernel this message is being read by the process P2. So this is the difference between shared memory and the message passing model. Okay. Now let us see some more information about shared memory and message passing model. First one is that shared memory allows maximum speed and convenience of communication, as it can be done at the memory speed within a computer. So what they say is it is at the memory speed. Why? Because we are creating a shared memory area wherein the processes can share and exchange data and information. Whereas in message passing model, you are involving the kernel by sending the message to the kernel, and from kernel you are sending the message to the process which is sharing the data, right? It is faster than message passing, as message passing are typically implemented using system calls and thus requires more time consuming task of kernel intervention. So why they say it is more time consuming? Because we are involving the kernel in order to share information. Okay, in shared memory system calls are required only to establish the shared memory region, whereas in message passing system, every time you send a message you have to have a system call and involve the kernel, and from kernel it has to be sent to the other process. Whereas in shared memory model, system call is required only to establish the shared memory region of the process which is willing to share the information. Okay. The next is, once the shared memory is established, all the accesses are treated as routine. So it is not treated as system calls, it is treated as routines, and no assistance from the kernel is required. Then interprocess communication using shared memory requires communicating processes that to establish a region of shared memory. So it is like interprocess communication takes place through shared memory, and only to establish the shared memory region we require a system call, right? The next is a shared memory region resides, that is what as I said earlier, shared memory region resides in the address space of the process which is creating the shared memory segment. That is, when you look at this diagram, the shared memory region is being created by process P1, right? And this shared memory region resides in the address space of process P1, and in that address space only the P1 is creating a separate region called shared memory region. So this is what they are trying to say in that shared memory region resides in the address space of process creating the shared memory segment. So process P1 is creating a shared memory segment, so it resides in the memory space of process P1. The other process that wish to communicate using the shared memory segment must attach it to their address space. So process P2 should get attached to the region which has been shared by the process P1 and read the information. Okay. The next is, let us see a few more points about message passing. Message passing is useful for exchanging smaller amount of data. So this type of involving the kernel and sending the message to the other process, we can do that work when we are exchanging smaller amount of data, because there need to be there is no need to avoid any conflict, and it is also easy to implement than shared memory for interprocess communication. Why? Because when you are exchanging only smaller amount of data, it can be easily passed through the kernel, but when you are sharing a larger amount of data, shared memory model is more convenient. Okay. So thus these are the two most important models under interprocess communication, and it is the most important topic in operating system under the subtopic interprocess communication. Okay. So far we have completed these many topics, and now we completed interprocess communication. The next is CPU scheduling criteria. Okay. So my next topic will be CPU scheduling criteria. Okay. Thank you for watching my video, and if you like my video lecture, please do like, share and subscribe my video, my YouTube channel, and don't forget to press the bell icon. And these are my socials. We are available in Instagram and Facebook as well. Please do follow us in Instagram and Facebook as well. Thank you.